With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone. So the question is, two blocks of equal mass small m are connected by an unstretched spring and the system is kept at rest on a frictionless horizontal surface. A constant force F is applied on one of the blocks, pulling it away from the other as shown in figure. A. Find the position of center of mass at time t. B. If the extension of the spring is x0 at time t, find the displacement. Find the displacement of two blocks at this instant. Okay, so we need to find the displacement of two blocks at the instant t and also the position of center of mass at time t. So for position of center of mass at time t, we know it's very easy that force acting on center of mass is what? F. And acceleration of center of mass can be given by total force on center of mass upon total mass of system, which comes out to be acceleration of center of mass comes out to be F upon 2m. Okay, from here using S equals to ut plus half at square, S equals to ut plus half a t square, we know initially it is given that the system is at rest. Therefore, u comes out to be 0. So as u is 0, S equals to half acceleration of center of mass is F by 2m t square. This comes out to be F t square by 4m. Okay, so this is the position of center of mass at a time t. So this is the position of center of mass. Now if the extension of that spring is x0 at time t, find the displacement of the two blocks. Now extension is given to be x0 at this time t. Now we need to find the displacement of the two blocks. For that we will, to find the displacement of each block, let's assume that first block is moved by a distance x1 and second block has moved by a distance x2, and we know that center of mass of the system is what? X. So from here we know that x equals to mx1 plus mx2 upon 2m. So this is center of mass of the system, this is the displacement of mass m, and this is the displacement of the other block. Okay, so from here we know that x is equals to s, because x is what? Center of mass position, and this was the center of mass position. So this is equal to f t square by 4m. Now x1 plus x2 from here comes out to be x1 plus x2 comes out to be f t square upon 2m. Okay, so this is going to be the value of x1 plus 2. Now extension in the spring, talking about the extension in the spring. Extension in the spring is going to be what? x2 minus x1, because x2 minus x1 is going to be the extension in the spring, because distance traveled by x2. Suppose this due to block A, this the extension in the spring is x2, but in the same direction block B will travel, so the compression in the spring will be x1. So the net extension in the spring will be x2 minus x1. So let's say x2 minus x1 comes out to be x0, that is extension in the spring which is given in the question. So from here there are two equations, x1 plus x2 is given, and then x2 minus x1 is also given. We can find out the values of x1 and x2 by adding and subtracting these two equations. Suppose first of all we add these two equations, then we will get the value of what? X2. So 2x2 comes out to be ft upon 2m. Upon adding these two equations, it is ft square upon 2m equals plus x naught. This is x2, which means x2 comes out to be half f t square upon 2m plus x naught. Similarly, x1 will come out to be half f t square upon 2m minus x naught. Okay, so these are the values of x1 and x2, that is displacement of block 1 and displacement of block 2. Okay, so in this question we found out the position of center of mass and displacement of each block. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.